Hello everyone, gonna watch the 5-3 video here today, um, inequalities in one triangle. So our objectives are to recognize and apply properties of inequalities to the measures of the angles of a triangle, and two, to recognize and apply properties of inequalities to the relationship between the angles and the sides of a triangle. Okay. So key concept here, definition of an inequality, guys. For any real numbers a and b, a is greater than b if and only if there is a positive number c, such that a equals b plus c, guys. If you can add something to b to make it equal, well then of course a is greater than b. Alright, and then guys, we got properties of inequality for real numbers. So, guys, comparison property, a is less than b, a is equal to b, or a is greater than b. Because one of the three has to be true. Guys, transitive property, just like transitive property of equality, okay? If a is less than b and b is less than c, well, then a is certainly less than c. Guys, works for greater than. Addition property, guys, you can add the same thing to both sides. Inequality is still true. Subtraction property, you can subtract from both sides, and the inequality is still true. Okay, so theorem 5.8 is our exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So guys, here angle 1, that's the exterior angle that we have highlighted here, because it's greater than either A or B. Because it's greater than either of the remote interiors. Angle 1 is greater than A, it's greater than B. Because of course, this comes from the fact that, guys, remember the exterior angle inequality, or exterior angle theorem, guys, that's that the exterior angle, measure angle 1, is equal to the sum of the remote interiors. So if angle 1 is equal to those two added together, well then certainly angle 1, well, it's going to be greater than either of the two angles. So that's from chapter 4. Right. So use the exterior angle inequality theorem. Guys, here we've got a pretty complex drawing. Quite a few angles that would be labeled exterior here. Okay. So use the exterior angle inequality theorem to list all of the angles that satisfy the stated condition. Measures less than 7, so let's locate 7. So 7, that's this exterior angle. So what would remote interior angles be? Okay, of course 5 and 4, they're in the interior of that triangle, so angle 5, angle 4, yep. Now if we looked at the bigger triangle here, the largest triangle that goes here, well then 1 is a remote interior. Okay, well 2 and 4 would combine to make a remote interior. Of course 4 is less than it, so 2 can also be added to that list. It's a really sloppy 2 there. And, well, that's going to be it. 5, 4, 1, and 2. Those are my remote interior angles. Okay, of course, 2 is part of a remote interior. Again, 2 is part of this angle. Well, if the whole angle is smaller than 7, then certainly 2 is smaller than 7. So, a little asterisk there to keep that in mind. All right, so measures greater than angle 6. So, well, let's locate angle. Let me erase some of my markings here from the previous problem. Let's locate angle 6 here. So that's an interior angle. Okay, so angles greater than it would be exterior angles. So certainly is 3. 3 is an exterior angle to 6, angle 3. What other ones would be greater than 6? exterior angles to 6, we could certainly look at this bigger triangle again, where we have the exterior angle 8, and its remote interior angles would be 1 and 6, so angle 8 would be included. Okay, and other than those two, I'm not sure that the exterior angle theorem applies. So 3 and 8 for sure. Okay, so now we're going to talk about angle and side inequalities, which is very similar here. Okay, guys, the relationships between angles and sides. So the longest side is opposite the largest angle. The smallest or shortest side is opposite the smallest angle. Okay, so angle-side relationships in triangles. If one side of a triangle is longer than another side of the triangle, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Guys, and similarly, if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So it can work for sides and it can work for angles is basically what we're getting here for 5, 9, and 5, 10. All right, so list the angles of PQR in order from smallest to largest. So the smallest angle is opposite the shortest side. What's the shortest side? 7.5. So the smallest angle is Q. Angle Q is the smallest. The longest side is 9.1. So the largest angle is angle P. That's the largest. And then, guys, of course, we've got one angle inside left here, 8.8, which is the middle. And so certainly angle R is going to be in the middle as far as angles go as well. Okay. And this next problem, guys, and the last problem on our notes, we're going to do the same with listing sides. Okay, shortest to longest. Okay. The trouble here, we don't know angle F, but we do know that these three angles, we know that they add to 180, so we can find angle F. So 45 and 56, 101. So angle F is 79 degrees. All right, so shortest side opposite the smallest angle. Smallest angle is 45. So the shortest side is F. H. Let's do it again. So longest side is opposite biggest angle. 79 is the biggest angle. So the longest side is GH. And we're left with one more side, guys, 56. That's in between 45 and 79. So that side that's opposite it, GF, is going to be the middle length. Okay? So your homework, guys, you'll have a little bit of both types of these problems here on your practice 5-3. Thanks for watching. Hopefully we found this pretty simple. Have a wonderful afternoon.